Hello, and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the ITX product. Today's topic is leveraging the ITX REST API for SWIFT. Please feel free to follow me on Twitter at PaulBrettIBM. Within the range of IBM Transformation Extender products, you will find packs that are specific to industry standards. One of those packs is the IBM ITX Pack for financial payments. In today's demo, I will be taking elements of this pack, notably the metadata in the form of a type tree, from the SWIFT part. I will use this type tree to build a map that can validate an MT950 SWIFT message. Then I will expose that as a service using the REST API for third-party software to call. I'm going to do this demonstration in 3 parts. I'm going to start in the Design Studio, then I'm going to move my project to the Design Server, and finally I'm going to deploy that to the REST API. Now I could do it in 2 parts and start with the Design Server, but for clarity I'm going to start with the Design Studio and then do an import. Okay, so here we are in the Design Studio. As you can see, I've created a project called SWIFT, which is currently empty. And I have an Explorer window open on my project directory. First thing I'm going to need is a couple of items from the SWIFT pack directory. So let's open that now. If I go into the packs subdirectory of my ITX 10 installation, I have a pack called Financial Payments 10.1, and then within there I have a SWIFT subdirectory. I'm going to go into the MT, type trees, and I'm going to grab a copy of the SWIFT ISO 7775 2020 MTT type tree file. Okay, while I'm here, I'm also going to grab an example file. LMF to LMF. There we go, we have an input file. I'm going to rename that to input.txt. Okay, so we have our type tree and we have an input file. We need to build all the rest of the elements from this point forward. So back to the project, I hit the refresh key and we have our SWIFT tree and we have our input file. I'm going to create another type tree at this point. I'm just going to create a type tree called generic. And within that type tree, I'm just going to have one item called text item, which is just going to be infinite length text blob to handle generic items within my map. Tree. Okay, let's start the map file now. So let's go and call that example.mms in the SWIFT project. And we're going to start a new map and we're going to call this validate MT950. For the input card, which I shall call M1, we are going to use the type tree that I grabbed from the SWIFT pack, SWIFT ISO 7775. And the object I'm going to pick is MT950 from SWIFT batch category 9. The file I'm going to read is input.txt. I'm going to go into the map settings here and change workspace to memory for speed, and I'm going to turn the audit on and change the audit file name to the default so we can see what's going on. So the map has been saved, built and run, and if we have a look in our SWIFT directory, we will see that we have an audit log, which I shall open now. It says here that the map has completed successfully, the map is valid, the return code is 0, and the data has been validated. It's 2,375 bytes, and it is a valid MT950 SWIFT message. This is good, but it doesn't really report anything back to us at the moment. So that's what we need to do now, build a map that we can use in our REST API that will utilize this map and give us some kind of feedback. So let's just close that for the moment and add another map. New map is going to be called report MT950. Let's create a new input card. We'll call this in1. The type tree we're going to use is the generic one I created earlier, the object being text item. I'm going to just utilize the echo adapter here at the moment and just send in some garbage. On the output side, let's call our card out1. We are going to use the same type tree again, generic, just a simple text item. And we're going to report to output.txt. Okay, what we're going to do is use a valid function to do one of two things. If the next sequence is valid, we will get the result of it. If it's not, it will do the second argument. So the first thing we're going to do is a run function. I'm going to run the map validate MT950. I'm going to echo in to card 1 the content of my current card 1, and that's the run function finished. So what to do if the file is not valid? Well, we're just going to report the word fail and add on last error MSG, and that is the rule complete. Okay, so just remember, on the input side we're sending in some garbage 5 characters. So if we save, build and run, you would expect that our output card would say that there was a problem. If we have a look at our output card here, it's reporting the number 28, which isn't very helpful, which means that we're getting the result of the run function. The valid hasn't kicked in, but obviously 28 is not a 0, so it's not valid. What's going on here? What it is 28 is a warning code and is not tripping the valid function at the moment. We just need to add something else to our run function, and I'm going to copy this from a text file that I prepared earlier. I'm going to do an override for the run to say that all of the following warning codes need to be treated as failures. So if we now, before we run this, let's just have a quick look at the audit log on that last run. You can see that the map status is warning, the map return was 28. So we'll just run that again now that we've added in these extra codes. So save, build, run. Now we get the output fail input type contains errors. I'll remind you again, this is because the input card we're currently sending in the garbage 5 characters 1, 2, 3, 4, 5. So let's change my input now to actually read a file instead. The file we're going to read is input.txt. So this is the actual good MT950. Save, build, run. And now we get the correct output from the map, which is a 0 to indicate that the file is valid. Okay, so that's enough work in the Design Studio. Time to package this lot up and get it over to the design server for continued processing. So I'm just going to close the map, I'm going to close the Design Studio, and in my File Explorer I'm just going to remove all the files that are created temporary and we just don't need them. Leaving me with my map source file, my 2 type trees and my input file. I am going to copy those to a zip archive, and in the next stage of the project next stage of the demo, I'm going to import that into Design Server. Here we are in the Transformation Extender 10.1 Design Server. I've accessed this through a browser and by entering the URL to the main page. I'm going to log in now, and as you can see I have no projects at all at the moment. So we're going to import one. Let's import the swift.zip that we created in the previous step. Okay, that's imported. Let's have a look what we've got. We have two maps. We have report MT950 and validate MT950. We have two schemas. We have the generic that we created and the Swift ISO 7775 that we copied from the Swift pack. And finally we have our file, our valid MT950 file stored as input.txt. So let's have a look at those maps. Let's start with validate MT950. This map will need to be built in this environment, so let's do that now. Okay, this map has been built successfully. Let's open our report MT950, and as you can see is exactly the same map as before. So let's build and run this map now. If we have a look at the output data, you can see that we have a 0 to indicate that the file was valid. So it's all working exactly the same as it did in Design Studio. We do need to make two minor changes to this map ready to deploy it to the REST API. On the input card side, we need to go into the settings and say that the input card 1 is the REST input. And on the output card, we need to also change the settings. In the action properties, we need to say that this card is the REST output. Okay, that's those changes finished. Let's save and build this map one more time. Okay, so these maps are now ready to deploy to the REST API. So let's do that step. Let's close the maps and back to home. From the deploy section, you can see that I have a server defined. I've called it local REST API. And if we bring up the properties, you can see that it shares the IP address .14 of my design server. It's deployed on the same machine. Let's go back to home and into packages. I'm going to create a new package. I'm going to call this package 1. From the project Swift, I'm going to grab the maps, report and validate MT950. I don't need to grab any extra files, it's just those two maps that I need. So we've added those to the package, and if we tick the package I can deploy to my local REST API. Okay, before I hit the deploy button here, let me just show you that on the endpoints page for the REST API, which I've accessed through the URL, I refresh here, you can see that there are no endpoints deployed. Back to my design server, hit the deploy button, deployed successfully. Back on the endpoints page, hit refresh, and you will see that I now have my validate MT950 and my report MT950 maps ready to run either synchronously or asynchronously. Now the one that we're going to run directly is report MT950. So let's give that a try now. I'm not going to bother providing any input or any output. I'm not going to bother choosing a file. I'm just going to hit execute. And that's going to give us an error saying that I didn't actually provide a file or any kind of input. But what it has given me is an example curl command to start with, to build up my curl command at the command line to demonstrate the next section. So let's do that now. Let's open a command prompt and let's paste in the curl command that we have. Make this a bit bigger. Okay, so here's the basic curl command from that page all the way up until this point here. I've added on an extra piece, /data-binary, and then within double quotes and with the @ symbol at the front, I've specified a file. Now I've got a file here called mt950.good.txt. This is exactly the same as the input.txt we were using earlier. When I execute this command line, what we get back is a 0 from the REST API. Now bear in mind that this curl command is actually making a REST API call to a remote machine. We are utilizing the power of ITX and specifically the SWIFT pack to validate a message and then report back on the answers, on the result. So obviously I'm using curl here, but this REST API call can be made from any third-party application that can make REST API calls, and even some that can't. For example, you could bypass the lack of a REST API call if you can call Java code, and then from Java code you can make a REST API call. So you can basically leverage the power of the ITX transformation engine and the SWIFT pack from pretty much any application. Let's send in a bad file here and show you what happens when we don't have a valid file. This is where we get our message back that we designed earlier, and this tells us that one or more inputs was invalid. And the reason for this is that my mt950.bad.txt has one line missing from the file. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, please remember to hit that like button. Consider subscribing to my YouTube channel as I release relevant content such as this on a regular basis. Reach out to me on Twitter at PaulBrettIBM. Thank you.